Welcome to the interview series on the socioeconomic consequences the socioeconomic consequences of disruptive technologies by rethinking economics now. Since many of the topics today we discussed so far are quite qualitative in nature, we will now be moving towards a more quantitative subject. And this should be something which economists more focused on the quantitative side should be able to jump right into, namely mechanism design. This interdisciplinary field, which combines economics, computational science, and mathematics, and many more, roughly translates to designing of economic mechanisms such that rational agents are incentivized to take actions such that the goal of an optimal outcome is achieved. To tell us more about this, 5 experts from the Mechanism Design for Social Good Community, or MD4SG, have been so kind as to join us today. Firstly with us today is Jessie Finucalo. She is a PhD student at Computer Science Theory Group at the University of Colorado Boulder. She's working with Dr. Rafael Fundillo and unofficially with Dr. Bo Wagner. In general, her research interests intersect with theoretical machine learning, algorithmic game theory, and computational economics. She's interested in decision-making in the midst of uncertainty, how the questions we ask affect what we learn, and how the uncertainty affects people. Secondly, with today is Anna Andrea Stoica. She is a PhD student from the computer science at Columbia University, working with Professor Augustin Chantrot on social networks and algorithmic fairness. Her work focuses on mathematical models, data analysis, and policy implications for algorithmic design in social networks. In particular, she is interested in studying the network structure, how it affects on algorithmic bias through the Crab theoretical lens. Thirdly with us today is Sarah Lenardi. She is an associate professor of economics at the University of Pittsburgh. She received a PhD in social science at the California Institute of Technology in 2010 and is an experimental economist. In the School of Public Affairs, Lenardi believes in the solutions to real-world problems transcend disciplinary boundaries, to touch upon human motivations. She is also the founding director of the Center for Analytical Approaches to Social Innovation, also at the University of Pittsburgh, which aims to connect mathematical and computational social science with the practical challenges faced by organizations serving vulnerable populations. Fourthly with us today is Freda Bonaccio. She is a PhD candidate in management science and engineering at Stanford University, advised by Professor Itai Aslage. Her work focuses on market design and the study of real-life socioeconomic problems that arise in matching markets and digital platforms. She's particularly interested in the design of effective and fair admission policies in education, the issue of bias and discrimination in online labor markets, as well as the role of information design in non-monetary matching markets. Freda's research has been supported by various fellowships from Stanford Data Science Institute, Stanford School of Engineering, Google, and many others. Lastly with today is Lily Su. She is a PhD student studying computer science at Harvard University, advised by Professor Milan Tambe. Research applies online learning and game theory to wildlife conservation. She is focused on the prevention of illegal wildlife poaching. Her work on predictive models to prevent poaching is being deployed to 800 protected areas around the world using the smart conservation software. She's passionate about reducing a negative impact on the environment and increasing a positive impact on society. And with that, I would like to move towards the first question of today. Jessie, I believe that the focus of each of your work could be summarized under the term mechanism design. Could you explain to us what mechanism design precisely is, perhaps through an example of your own work?
Yeah, first of all, thanks for having us. And maybe I'll say to everyone else, like, when I inevitably leave something out, please feel free to add in and supplement my answers. But mechanism design, I would say, is a cross-disciplinary area of research. And it goes, I mean, even today we have people in operations research, economics, computer science. A lot of mathematicians do it. And it's really something that I would say everyone is familiar with, but maybe not with its mathematical formalization. And so when maybe it's easier to think about examples of what mechanism design is. So something like an auction, if someone has an item and they're trying to decide who out of the rest of us to give the item to, and they want to sell the item, how do they decide who the winner of that auction is? They decide that through a mechanism. And that's maybe one simple example, but you could think about how allocated, like food at food banks donated food gets matched to food banks. That maybe a donation center works in multiple food banks who gets what supplies, and they want to make sure that food doesn't go or it doesn't expire without being given out. Everybody gets some nutritional supplement. We could also think about a classic example is matching doctoral residents to hospitals. So everyone has their preferences over what specialties and what hospitals they want to be in, but not every hospital can accommodate everyone who wants to be there. How do you match residents to hospitals? And these are all examples of mechanisms. And so if you are familiar with game theory, typically you're given some scenario, and in game theory, we often study like, okay, what strategy should I play in order to best play this game? And mechanism design kind of asks some inverse question about, okay, how do I design this game so that the people playing it will satisfy whatever things that we desire to learn from them? Maybe it's that they actually report their beliefs, whatever that means, honestly with us. And maybe we want it to be individually rational so that they only participate if they expect to win, things like this.
Yeah, I also heard the term reverse game theory for it, or basically that it's the exact opposite of what economists are doing. Instead of studying the market, we're designing it. Anna, I was wondering, I see people not, so I assume that that's the correct definition. Anna, each of you is also involved in the mechanism design for social good community. Could you expand on what exactly the community is and how exactly, and I do think that Jesse already pointed this out quite well, but perhaps some more examples on how you exactly can improve the social good with mechanism design.
Definitely. Thank you, Cohen. Thank you for inviting me and all of us here. I very much concur with Jesse's definition of mechanism design, and I'll start by saying that I've been involved with mechanism design for social good, with MD4SG for short, for about 2 years now. And it's been really wonderful to see this community growing from an initial reading group to now a really large group of a few hundred very active members that come from very different areas, from academics, as well as from industry, nonprofits, and government and policy people. So it's a very multidisciplinary group that tries to combine different computational methods related to mechanism design, related to applications to social good. And those applications are related to the kind of working groups that are the pillars of this organization, that are groups that meet online every couple of weeks and work on projects related to social good. So to give an example of what those are, we have working groups that are related to environment and climate change, to developing nations, to data markets, to civic participation, as well as bias, discrimination, and fairness issues, to inequality as well. And there's this semester, we're going to have 2 additional groups emerging as well. So in each of these groups, there's people coming from computer science, economics, operations research, as well as social sciences, and people who work in industry and nonprofits who come together and they try to find a problem that's important to solve that can improve the different access to opportunity that impacted communities receive. So some groups have been working with smallholder farmer startups that try to use computational methods to optimize the way that farming is being done in different parts of Africa, for example. In one of the groups that I've been working on, I can give an example of a project we've been working on that Jesse and Fedra have been leading, that is related to how do we define bias and discrimination in mechanism design versus machine learning. And there are different, so to identify gaps in between these fields and ways in which new research can bridge them. And as Jesse said, in mechanism design, oftentimes the notion of discrimination, of inequality permeates through notions of utility, individual welfare, and how people respond to a mechanism. When I see an auction, how would someone respond to it? When there's different resources that are being allocated, say through governmental services, how do people retain that service? How do they respond to it? How do we target them better? in opposition, and the recent developments in machine learning tackle this problem of discrimination at a larger group level statistics, and involve the design of different algorithms that try to allocate these also resources, but at a very large scale level, focusing on a group, different demographic groups. So our project focused on identifying these gaps and trying to find new avenues of research in which, for example, when we use machine learning algorithms to allocate certain services, oftentimes we use it for diffusing information, learning about jobs, in school admissions more recently, as well as in seeing the ads that we see online nowadays. How do people respond to those algorithms? How can we learn what mechanism design has been doing for so long to incorporate this in the design of the algorithms? And conversely, what can we learn from the way machine learning has been working with very large scale data sets, and with learning about the feedback loops that are being created through these algorithms, and how can we incorporate these notions into mechanisms that we design for allocating resources as well. So this project is very much in between, let's say, a position paper and the survey, and it's now followed up by different projects we're working on that are following up on the new directions of research discovered in this. And I know my colleagues have a lot of very interesting projects to talk about, so I'll let them follow up on that too.
Yeah, I think it gives a very interesting overview of the whole field, and especially I think that as an economist you have many terms which, even without being familiar with mechanism design, you will have heard of in your studies. So Sarah, I was wondering, could you expand on terms on the things from mechanism design which actually also are similar in economics? So how does it relate in those ways? So which areas of focus, terms of methodologies, ways of thinking? And I do recognize already quite a few. Will they likely already be familiar with? And perhaps do you an example from your own work which illustrates this?
Thanks, Colin. Thanks for having us. So, I'll just go in primitives here, right? So economics is basically the study of how to allocate of scarce resources. And then in economics, you see demand and supply, right, all the time. And so demand is basically how people value a certain thing. And supply is basically how much it costs for someone to produce something, right? And then the methods that we often see is optimization. We assume that people respond to incentives. And so we always see marginal benefit equals to marginal cost, right? And then, so if you don't have this response to incentive, then you cannot go into mechanism design. So for example, if people increase the price of soda, then people assume to be buying less soda, right? So you take these primitives and then you go into mechanism design. And so mechanism design is how to design incentives such that you can obtain certain outcomes, right? So this outcomes could be, I want to maximize social welfare, or I want the most number of people to be using this good, right? And so, so as you can see, like the method is the incentives. The incentives is based on the valuation and the production, right? And so the two are absolutely related, right? So as designer of the systems, we add more into this. Like we also usually have a whole host of constraints that we put in. Like we say, we want to design mechanisms so that nobody feels forced, like what Jesse was saying, right? You don't have to participate if it doesn't make sense to you, or that the system will work even if we make the wrong assumptions, like what Anna was saying, like when they were working with groups like small farmers, we don't completely know their decision-making environment. And so we would want to create an incentive system or a system that can work even if what we think about the population is not correct. All right, so so my area is in behavioral and experimental economics, and like specifically what I think about, what I work on is like the pipeline of social service kind of like production, right? So on one end, you have people who volunteer or who donate, right? Like either time or money, and on that end, and then the other end would be like the clients that are using, the systems that we produce. And so on the people on the production side, what I try to understand are these, how do they respond to non-monetary incentives, right? So a lot of people here are actually responding out of intrinsic motivation. And so the incentives that work there, some of them are about, understanding the amount of good that they're doing, or status, or visibility. And so there's like a whole bunch of incentive design that is happening there that's like a non-monetary kind of incentive design, right? So so there's a whole field of pro-social behavior and behavioral economics that is just studying how people respond to this trickier, like, non-monetary things. And then on the other end, you have the clients. And so here we work a lot with through field experiments. So we work with people who have experienced homelessness or have been incarcerated, or people who are experiencing like work instability, job instability. And we ask like a couple things, right? So one is we try through immersion to understand what is their decision-making environment, right? How do they value the services that we're putting out? How do they value time? What are their production costs, right? So what we think our production costs are, because we live in such a segregated society in terms of socioeconomic statuses, it's very hard to actually know what the value and the production, functions and cost and distribution of types and all these things are in the population that we intend to benefit, right? So there's work there in trying to understand the decision-making environment. And then there's another set of work, which is that a lot of our incentives are around, monetary incentives, subsidies, competition, etc., right? But do they work when we apply them to this environment? So so that's kind of like, I hope I covered through like some of the primitives and the typically hard terms in economics and how they're, the same things that we do in mechanism design, and like provide some example of how when you put behavioral and experimental economics on this, you are investigating these primitives and applying them. Okay, thank you.
I think it's a great overview as well of the economic aspect, but also the empirical foundations that really of the research and the applications. Vedra, I was hoping that you could expand on some terms and methodology and ways of thinking which might be new for economists. Other things which are taken from other disciplines, such as machine learning. And could you explain these things as well to concepts from your own research or your own research?
Yeah, definitely. I can give you two examples. Anna briefly mentioned one project that we have, which is a paper from our MT4AG working group, which I believe touches upon several ways that mechanism design and machine learning can learn from each other to improve fairness and equity in real life socio-technical systems that we are all familiar with. And to give you some context, FairML has offered several technical definitions of fairness. It also has proposed some preliminary technical solutions, but most importantly for me, has helped draw attention to certain ethics questions and fairness and equity concerns around the use of AI and algorithms for decision making. And many of the applications that fair machine learning has studied include classic areas of research for mechanism design, such as online advertising, labor markets, digital platforms, college admissions, and so on. So although we have noticed that within the field of mechanism design, the study of fairness and equity metrics and concerns exist, it has mostly focused on social welfare. However, we shouldn't, of course, forget that there is a whole literature in labor economics about discrimination and affirmative action. And we, of course, emphasize that in the paper that ML should also learn from those papers. But on the other hand, we believe that mechanism design could benefit a lot from drawing upon work on fair machine learning, of course, through a critical lens. And I also find particularly encouraging in general in this field of fair machine learning, the fact that fair ML researchers often try to inform their research with knowledge from other fields, such as philosophy, law, and sociology, which is a great example for a great lesson for economists as well. To give you a second more concrete example from my research on how mechanism design and ML can actually collaborate with each other, let me talk about a recent paper my co-authors and I wrote about a classic market design problem, which is college admissions. So this is motivated by a recent debate in the United States that started from the recent decision of University of California and other universities to drop the standardized test score requirement. So we studied this question, and specifically whether dropping standardized test score requirement will help design a more fair and efficient admissions process. So to answer this question, on the one hand, we build on a classics economics model by Phelps, but to define fairness, we actually draw upon recent definitions from the machine learning literature, like group and individual fairness, but also relaxed notions of these definitions, such as diversity and the gap between admissions probabilities across groups. So on top of these technical knowledge that we use from economics and machine learning, we also review extensively the sociology research on this topic to inform our model assumptions and know more about the problem. So I believe that such interdisciplinary approach, combining theory and data insights, but also knowledge from other fields, is necessary for providing a more complete answer to important mechanism design problems, and would be a great way for economists to study such problems.
That sounds really interesting. It's also really interesting to see that underlying everything is still the economic assumption of rationality, to see that is the underlying, I think, in all the answers. Lily, I was hoping, could you expand on how we can apply sustainability? This is also such an incredibly important topic, and it is really interesting to see how your research shows that mechanism design can contribute there as well.
Yes, thank you, Cohen. As Jesse and Sarah described earlier, the goal of mechanism design is to help inform policymakers as they design solutions to get the individual incentives of agents, who are often selfish, to align with social incentives. So a famous problem where these incentives do not align is the tragedy of the commons, where a rational agent will overexploit natural resources, such as a fish stock, for the temporary gain, but at the expense of society's long-term benefit. So misaligned incentives are really at the heart of the majority of our environmental issues, from deforestation to biodiversity loss, climate change, energy inequity, and climate injustice. These are all rooted in settings where the individuals are incentivized to take actions that are not best for society. And as Sarah mentioned, trying to figure out how to allocate scarce resources to help readjust the incentives is at the heart of economics and at mechanism design. So there's all sorts of optimization questions there as well. So my research focused on one of these problems, looking at questions of sequential decision making, because we have to make sure that these incentives are going to continue to progress over time to make best decisions and optimize social welfare in the long run. And also using game theory for wildlife conservation. And my work specifically looks at the poaching domain. So in protected areas, we have poachers who lay out snares to try to catch animals, and we have rangers who conduct patrols to try to remove as many of these snares as possible. And we anticipate that poachers will try to avoid getting caught and will respond to ranger patrols by changing their poaching strategies and putting snares in different areas. So our goal is to plan ranger patrols to sort of go towards these poaching hotspots, but anticipating that poachers will react accordingly in this game theoretic way. So the challenge is to plan patrols in a sequential way, anticipating this game theoretic interaction. And in general, I think that mechanism design and sustainability should also help us motivate and think about how we can change the incentive structure in these poacher domains as well, to help not only discourage them from placing snares, but also to motivate them and incentivize them to pursue alternative livelihoods by making sustainable alternatives more economically attractive.
I think that's I think that's so interesting about each of your answers is that I think a lot of us in economic studies, we basically get a lot of these game theoretic problems. I just had a whole course on game theory, and you sometimes wonder what am I going to use this for? What is the real life application? I think it shows beautifully that you can actually use this to stop poaching. So that's absolutely beautiful. Jesse, I was hoping you could also expand a bit more on how it, I think that Freda already covered this a bit, but how it exactly relates more to machine learning. Do you have further examples of that?
Yeah. So I guess just like at the highest level, we can think about how mechanism design and machine learning are both presenting algorithmic decision-making systems, and not necessarily like, I know a lot of people hear algorithms and they're like, oh yes, the computer. But I loosely mean algorithm as in like any like defined set of steps that leads you from input to output. Oftentimes in the mechanism design setting, it's preferences or reports or types, where in machine learning, I think we're increasingly, or maybe this is my observation bias, but I think we're increasingly seeing essentially we get like vector or just a list of information about a person, and I think that's kind of the current trend. But a lot of times we see information about a person and then we make a decision about that person. So Pedro mentioned the college decision example. Like you get someone's GPA, their SAT score, and like we all of a sudden have like quantified something that's inherently human and we've made a decision about it. And I think as machine learning kind of gets added into more and more places, we've talked a bit about the paper that we have where there are lessons that I don't think that either mechanism design on its own in theory is always practical or appropriate, depending on the context. And I would very strongly say the same thing about machine learning. But I think that they relate and that there's a lot of lessons that they each have to learn from the other. So Phaedra mentioned this earlier, but like a lot of machine learning papers recently have started to think about strategic input. So someone pays for SAT tutoring in order to make themselves look more appealing to a college. And a lot of times we've used mechanism design tools in order to think about these concepts and apply them to machine learning. So I think that the fields are, I wouldn't say necessarily moving together, but I think that they are starting to learn a lot from each other.
Anna and Phaedra, I have a question for the both of you, and then I have a very similar question for Sarah. What I found so interesting to see is that each of you has a bachelor, each of the interviewees actually has a bachelor in either computer science or mathematics. While you're focusing now on what could be described as a subfield of economics that took in the last decades a more computational turn, if I understood the literature correctly. How does your background on mathematics for Anna and your background on computational science for Phaedra influence how you approach this field? And do you have an idea how someone with a more economics background what approaches differently? Perhaps Anna could answer first and we could then move to Phaedra.
Yeah, definitely. I would say I started my undergrad by really being fascinated by the way people connect to each other. And the first field that I learned that from was from mathematics. But I soon learned that that was just a very, very small part of the way we model and understand these connections and the way people respond to algorithms. And I learned a lot more from engaging with courses in sociology, in economics, and although now I'm in computer science, these fields very much influence the work that I've been doing in working with social networks. So I would say that like the MD for SG community is a place where like I learned a lot about how these different fields approach these mechanisms of modeling connections, modeling the way we set interventions in a social network or how we diffuse information. And it's very much a process of interdisciplinary work that's been driving my research agenda for that. I would say what I learned most was that a lot of these theoretical questions that I used to study and I continue to study as well are not in a void. And it's really important to learn the social context to really understand and formulate the problem that is most important to study. So I would say that most of my work really focuses on, or like a big chunk of my time focuses on finding the right problem to solve. And that's where I'm really grateful for MD4SG for really focusing on that time and understanding how we center the communities that are disadvantaged. How do we find the right problem to solve, and where can our computational background be really helpful for that? And I would say for the last part of your question for students in economics, I think there's a lot of, as all my colleagues have mentioned, there's a lot of potential for interdisciplinary work. So I think we see a big rise in that, which means that the time we spend on finding the right problem to solve has increased a lot. And I hope that my piece of advice would be to say that that's not discouraging, and I hope it's not discouraging, but I think that's the right way to really think about these problems and to find new avenues and new ways in which different tools from economics and computer science kind of converge together to a similar application, and how we can work together in finding first the right problems to work on and then understanding what's our role in solving them.
Frieda, could you add as well for your perspective, perhaps also from your computational background?
Yeah, so I was an undergraduate student in electrical engineering and computer science. And during my undergraduate years, I had to take several very theoretical classes on math and physics. That was the curriculum then, and theoretical computer science, but also very hands-on engineering classes. And later in my undergraduate thesis, I worked on an algorithmic mechanism design problems, which is a field, which is an intersection of mechanism design and algorithms. And the challenge of that problem was to find the practical, computationally efficient, incentive-compatible mechanism that on the one hand approximates well the optimal solution, but on the other hand, it's not the optimal solution. And this was the first time that I appreciated the importance of approaching mechanism design problems through an engineering lens, and realize how aspects of a problem like computational efficiency or learning are actually very critical for designing good real-life systems such as digital platforms. And I believe that my engineering background has helped me improve my overall approach to research in mechanism design. And in my current research, where I use a lot of applied modeling, I always ask myself questions that an engineer would ask. For example, maybe this assumption is standard in the economics literature, but is it really reasonable to include this assumption in my model? Are my assumptions and results consistent with data-driven insights? Are the solutions that I offer practical enough to be implemented? Or even like, do they make sense? And what I most importantly ask myself continuously is, how can the solution be improved further, which is like a standard engineering approach to solving problems.
I was also curious, you mentioned the difficulty of the assumptions and choosing the right assumptions. Could you expand a bit more on that? Because I think this is something which economists also quite often struggle with within the models.
Me? Okay. So like, for example, one assumption I had struggled with was rationality of agents. And I often find like that certain problems, for example, to mention a problem from my research, which is related to discrimination in online labor markets, I found that maybe what describes well the user's behavior was not a fully rational and computationally very complex approach, but probably something very simple, like a simple heuristic that they use to approximate the optimal solution. And in fact, mathematically, this heuristic actually works very well. So why, in that case, assume that the agents are actually fully rational and not assume something that is, of course, less standard, but maybe works well and explains very well human behavior?
I'd love to come back to that also with the other interviewees, but I first had a question for Sarah, similar to the question I just asked Anna and Phaedra. So on your background, especially then, but you also moved from Adobe Systems, from the PDF library, and you work on there. How did it influence you? And especially when you moved from the more practical corporate computer theorist to that of an academic economic theorist, what surprised you?
Thank you, Con. Yeah, so I'm gonna touch on Phaedra's point just now too through that. So I was at Adobe. I was the PDF lead for PDF library in the core technology group, which means that we will all be writing functions for this big library that then gets compiled, and then the pieces of them goes out into software teams like Acrobat or Illustrator or Photoshop, right? So that very much like creates an impression in my head that like one of our function like as scientists is creating things that has a like one of the dimensions that's important is interoperability. Like things has like you should be able to use things in different settings, and there's modularity, right? Like you can cut things out into like functions and libraries and then like plug them into different places. And when I went into economics, I felt that that really wasn't true. I mean, one of the reasons why this wasn't true was that I went to Caltech, and so there's a lot of a lot of theoretical work, and so we have a lot of existence proofs, right? So you prove that an equilibrium exists, and then I'm like, how do we get there? They're like, it exists, and I was like, if there's no algorithm, like how do we get there? And if we don't know how we get there, how can we take two things together and put them into one? Like it made no sense to me, right? So I was really, really confused by that. And I mean, I still haven't completely resolved that, but like what Phaedra was saying about having an engineering perspective entering into economics was like, so one of the chapters on my dissertation is actually on information aggregation, which is like information is dispersed everywhere, and you create a system so that like people report information, it gets aggregated and gets put back out, and so you get this common knowledge of of whatever information it is, and it's all Bayesian, and I was like, wait, so you have this prior and you have this conditional that are very, very close to the prior, and you expect people to be able to update. And so for me, this was like very engineering-ish, right? I was like, well, what if there's noise? How many times would they have to update to get there? And so I started like, and I would like write these papers on this, and people say, this is an engineering paper, this is not really an economics paper. But then I ran experiments and I was like, yeah, people aren't able to update information there. It doesn't work. And if this doesn't work, and a lot of like what Phaedra was saying, if we know that people use heuristics, like why are we writing these papers that people are rational? That's because the literature is that, and there is so much of publishing so that you are, you're moving it along in the same direction, such that it's sometimes it's hard to bring those perspectives in. So yeah, thanks.
Yeah, I quite agree with you, because I think that this is one of the issues which we're also facing as economists, which you kind of just told, just move along. It's basically what we're assuming, and this is the way the world works, dot. And especially also with the assumptions that we raised earlier with perfect rationality. And I was also wondering for the others, because I saw that Lily and Jessie also nodded when we were discussing the perfect rationality. Perhaps first for Jessie, how do you see this, the assumption of perfect rationality? And have you also perhaps considered using different assumptions, such as bounded rationality from behavioral economics or different schools of economic thought?
Yeah, this is, I mean, I guess just like a personal like crisis that I've thought about a lot, because I don't want to do work that makes these false assumptions. And like I would love for my work to have like actual change in the world, but I don't want that change to be misguided and misinformed. And so I personally am very scared and hesitant a lot of times to make assumptions that I'm not confident and educated on. And so I think this is also partially me as someone who's more on the machine learning side of this like econ CS field. So my research with my advisor focuses on the design of loss functions for machine learning algorithms or scoring rules for people. And I oftentimes am not comfortable with talking about it in terms of scoring rules because of this like risk averse rationality assumption, where I'm more comfortable making that assumption that, yeah, a computer will optimize the problem you tell it to in a risk neutral way because that is the algorithm that it is taught. But that's just kind of my own little qualm.
Yeah, what seems difficult to me as well is indeed these assumptions that you have to, of course, you have to model the world. You have to make assumptions about human behavior in order to, especially within a game theoretic model, to use it. So, and I was wondering, so perhaps also for Lily, how do you deal with these issues?
I definitely agree that these kinds of modeling questions and assumptions are sort of at the heart of a lot of what we have to focus on as computational designers, especially working on these real world problems. And for example, in the conservation domain, it's not reasonable for us to assume that a lot of these poachers are rational actors, specifically because a rational actor would require complete observation of everything that's going on, complete observation of the defender strategy of where the patrollers are going. And obviously they can't do that. These parks are very large, a huge forest. And if the poachers could have perfect observations of the rangers, and the rangers could have perfect observations of the poachers, and then problem would be solved. So instead we have to really, really work with the data, the limited data that we have, and try to understand what are the patterns that we can actually see here, and what are the assumptions that are actually reasonable to make, so that we can have some decisions that make sense in the end. And what we found in this domain is that through analyzing real-world poaching data from a park in Uganda, we saw that the poachers don't necessarily respond rationally to everything that's going on in the park. They do respond somewhat rationally in very localized environments. So they're not taking into account the entire ranger strategy, but rather they're saying, what did the ranger do in this area in the last month? And if they poach there, in the last month, and then the rangers came, they'll realize, oh, my snares are taken. So let me move to a neighboring area that has some sort of similar geography, similar animal density and stuff.
So what interests me is that it seems that one of the advantages, at least for compared to a lot of the economic models, is the actual testability of the mechanism designs and such. I think that in economic it's very difficult to test their assumptions because basically the model is sometimes true by definition, which makes it very, very complex. Anna, I was wondering, how are you seeing these issues?
Hi, yeah, I think that's a very important question. How do we really test the modeling assumptions that we make? So I think there's different methods there. Like there's a lot of work to be done for this. There's one particular subfield that I've been learning more about like preference elicitation methods, in which we like really want to do more like empirical and measurement work to understand like what do people actually prefer when we assign a measure of utility. Is that actually in conformity with what we're actually doing? And I think that has a lot of potential to inform the models that we design, both in mechanism design and in machine learning. Oftentimes, the outcomes that we design for in machine learning algorithms are not necessarily informed by people's like preferences. There are subfields that like relate to that, but generally, we turn like the outcomes that we look at often look at like measures of accuracy of like, did we predict something correctly based on previous information? Did we do we how many or like what percentage of people receive a certain outcome compared to like the general population? And that may be in line sometimes with people's preferences of receiving that outcome and sometimes not. So I think there's a lot of work there that combines methods from other fields, like I think human-computer interaction, as well as like survey type methods, to really understand what are people's preferences. When we talk about issues like the project that Fedra has talked about as well, and like how do we understand discrimination in mechanism design versus machine learning? And there's been like recent works showing like, well, while we decide to be fair, maybe that's not in line with people's perception that that is a fair algorithm. And maybe that will influence the kind of strategy and decisions they make with respect to an algorithm. Maybe a recommendation they receive, if it's not perceived to be fair, it will not be taken into account. And that creates a feedback loop in the mechanism we're trying to design. So I think there's a lot of need for like this kind of empirical and survey-like work that has to inform first the questions we are forming and the kind of assumptions and modeling works that we are doing before we delve into like more theoretical questions.
Phaedra, I was hoping, could you also further expand on the comments of your colleagues? And I was also curious, have you considered taking completely different assumptions from rationality, and then perhaps not complete total irrationality, of course, but more really quite bounded forms of rationality?
Yeah, as I said, like I have used like both approaches, like depending on the problem. Sometimes I feel that the Bayesian approach may make sense because like the model is simple enough or not. But in other cases, and like the example I mentioned before, which is an online labor market, after studying the empirical literature and working on the model, I realized that a non-rational, maybe like bounded rational approach would make sense. And to explain what the problem was, I was looking at the online labor market and a problem of discrimination and social bias on learning from reviews. So I realized that based on the empirical evidence and what the empirical evidence was describing, people were actually following a simple averaging rule. So like they were basically looking at the average of the reviews. They were seeing at the website for a certain candidate employee, and maybe a prior belief, which could be a stereotype about a certain group or of employees. So instead of actually using like the Bayesian approach, which is very computationally complex, I ended up using a very simple averaging rule that actually approximated well the behavior that we see empirically, and conferred many of the other intuitions I had about the problem.
It's really interesting to see that the underlying logic of this is really closely aligned to the ways of thinking of the economists, especially the more empirical schools and such. Sarah, could you perhaps also expand on well, the comments, of course, of your colleagues, but also on how could the economists really get into this field, and how could it best contribute?
I think experimental economics is like a great bridge between the assumptions that we have and like relaxing rationality assumptions, like a step at a time, because you can test it you can test it in both sides, right? You can make a lab experiment that is extremely close to the theoretical decision-making environment. It gives you really precise, like, functional forms or whatever it is that you need for your decision theoretic models. And then at the other end, you can also uncover entirely different dimensions, for example, in a field experiment, right, where you see a much broader range of environments where a certain decision problem might take place in, and a much larger variation of populations that might be facing those decision problems. So I think the participation of experimental economists in this econ CS bridge could be very useful.
Well, the others also care to comment on their views and how an economist can really get into this field. Perhaps first, Lily?
I think the best way to get into a field like mechanism design for social good, I'm going to talk about that specifically and not just mechanism design, is to really focus on interdisciplinary learning, to make sure to take classes not just in the economics and computer science and mathematics, but also take classes in sociology and in gender studies and in African American studies. Because really understanding the problems in those domains is key to figure out what kind of problems are people not thinking about in the mechanism design community, and therefore start taking the perspective that you're learning in your economics class and in your computer science class to say, oh, I think this really looks like an auction problem. I think this really looks like a market matching problem. I think this really looks like some sort of graph and network structure problem. And that will give you the biggest leverage, because that will enable you to distinguish yourself from all the people who are only sociologists and all the people who are only computer scientists. And instead, you're sort of at this smaller sub-community and are much more able to sort of make an impact that way.
I would add to Lily's point of just volunteer in the area that you're interested in. You'll see so much.
Yes, it's very interesting. We see this especially like the interdisciplinary focus and the real world experience you gain through business volunteering. The importance of that is it's emphasized by almost every interview in this series. It's really interesting to see. Jesse, do you also have something to add related to the how an economist could really get into this?
I was mostly nodding in agreement with Lily's point. I think that it's super important to spend more time, or just as much, if not more time, being a student of the area that you're like applying for social good, as it is to focus on the mechanism design problem. But I don't know if I personally have insight, since I actually didn't even really know what economics was until I started grad school and kind of accidentally stumbled my way into this area, but very thankfully.
Yeah, for me, it's very similar with disciplines as AI and also history and philosophy and such. Anna, could you also expand on this? And could you perhaps also tell us a bit more on how students can get involved with the mechanism design for social good community, and what can they contribute and what can they bring to them?
Definitely. I think overall there's like way more chances now to get into like interdisciplinary work than before. So I think there's a lot of work that can be done at the forefront of like different research projects, as well as like engaging with like what problems are being solved in like day-to-day life as well. And related to MD4SG, there's a lot of, so I mentioned the working groups. This is a great way to get involved with like a hands-on, like a project or a topic that people are working on related to your interest, that combine methods from mechanism design and different applications to social good. And as everyone here mentioned, there's like different ones on climate and environment, on development, inequality, on bias and discrimination, on civic participation, and others. There's other ways as well. So we have a listserv of that's been like growing to a few hundred people now, through which we advertise our events. So we have a colloquium series where we invite different like domain experts to talk about the kind of work that they do, and it ranges from people in different domains. We had several economists who came and talked, like Al Roth and Matt Jackson and Lisa Cook most recently. And they talked about different ways in which they can combine their more like modeling and theoretical work with like real world problems and policy implications for like giving resources to people. There's other ways through our, we have like workshops throughout the year, and an annual event that so far took the place of a workshop as well, through which you can get involved. So we use this to like showcase work from our community at large, and people from outside the community as well who wish to get engaged in this. So that work takes the shape of different research papers, but also like problems and demonstrations, demos, and position papers that relate more to people bringing to the table different problems they've been working on and engaging in an interdisciplinary way with everyone else in the community. So these span, of course, people who come from academia, from economics, computer science, and so on, but also people who work in industry, people from different nonprofit organizations or startups who are seeking for collaborations as well. So these are just a few ways that you can, one could get involved, but as the organization is growing, these ways are also like increasing in variety and in numbers. So we're always welcoming people, and we're very open to the kind of ways we want to engage them.
Yeah, I myself also on the mailing list in the Slack. It's really interesting to see the events. Phaedra, before we move towards everyone's closing statements, for the last question for you, I was very curious about whether you had further tips on how an economist could get into the discipline of mechanism design. And besides I think the really is very important, as well as volunteering and really expanding your interest. Do you have further tips?
Yeah, I agree with all the previous comments. Like, I think like joining the MD4HG community like is a great way for junior researchers or like just like undergraduate students to learn more about this area, because like there is some effort. Like we all discuss papers, we read papers, we get involved in even in problems, but like it's a friendly community, and everybody's welcome, and I think like it's a great place to start research and start exploring new areas. An additional an additional tip I would have is to don't be afraid to challenge like ideas that you see, like that the students see in classes, and don't be afraid to combine also ideas that seem unrelated at first. And I think like especially like for younger researchers, like early stage PhD students or like undergraduate students starting research, it's a time to think out of the box and start exploring ideas that maybe other people like established in the field have not explored before.
Yes, I fully heartedly agree. So now as the closing statement, what we always have in this interview as the last question to each participant is, if there's one thing you could say to students in economics, the topic we discussed today, what would it be? And I think it will make most sense to also do it in the way we did with the starting question. So the first, the first person would like to ask this is Jessie.
Yeah, I think particularly in the context of mechanism design for social good, I think the one thing that I would want to say is to make sure and be wary about quantifying inherently human traits of people, and that a lot of times while we are equipped to think about optimization and algorithms, the core of these problems that we're thinking about are people. And so like this for someone could be a matter of life and death. And so just with that, to proceed both compassionately and carefully.
I think it's beautiful to see that economists basically have the same worries as the computer science, the mathematicians, when approaching this field. Anna, what would be your closing statements related to what is the one thing you'd love to say to students in economics related to the topics?
Yeah, I very much concur with what Jessie has said, and I would also say that I would maybe repeat what I said earlier, that finding the right problem to work on is sometimes a very daunting task, and it's something that I think is very important to find, like in developing like a research agenda and the right applications for someone's work, and that takes a lot of work and study of different fields and interdisciplinary work in domains that cross economics and perhaps other computational ones as well as non-computational ones. So I think that process is a very important one, and there are often many projects that come to that are difficult to pursue because this process being a daunting one. But I want to say to never be discouraged to do that, and to think about always that the methods and the designs that we are putting in place are never in a void. Although they're like seemingly neutral, they all have impact in the kind of assumptions we make and have a social context that basically shapes the kind of applications and outcome that we will see out of such a design. So I think these are very important like parts of research that we should give even more attention than we give now.
Interesting, thank you. Sarah, could you also say your last points? What would you love to give to students in economics related to this?
So I have 2 points. One is volunteer. The other one is learn to code. So, so volunteer, why? So it will humanize the thing that you're studying, and you'll get attached to something, and you will be humbled at like just how complex and how with all your training, you cannot make it, like you're trying to make a difference with this one thing and it's so difficult. Code, so that you start thinking about implementation, you start thinking about algorithm and design, which is something that we don't think enough about. That's it. Thank you.
He's really sad. Fedor, what will be for you the closing statements?
As a PhD student working in the intersection of many fields, I feel that my research has benefited a lot from adopting diverse methodologies and insights from many fields, but most importantly, actually working with researchers and other students from other fields. And we saw this actually in the MD4HD workshop we organized this summer, that the highest quality papers were actually papers that cross the boundaries between different fields, combine theoretical and empirical methodologies, combine science from technical fields such as economics, HCI, machine learning, but also law, philosophy, policy, sociology. So coming to your question, as a student, I believe that seeking collaborations with researchers and other students outside one's field and across a wide range of disciplines, in revisiting classic or new problems through this multidisciplinary lens can lead to the most exciting discoveries.
Yes, I fully agree. I always try to do it as well. Lily, what was for you the final question for today? What would it be for you?
I would say that as computationally minded researchers, it's very easy to think in terms of, I want to do social good, let's opt for something that's utilitarian. And in doing so, it's very easy to think about, okay, what will maximize social welfare? And then you're immediately targeting intervention for the majority class and people who are already advantaged in a lot of ways. So I want to make sure that you also think about, especially in dealing with questions of societal impact, who are the minority groups and marginalized members of these communities that are affected, who are actually most impacted by these challenges. And hopefully they're the most elevated by your potential solution as well.
I think that's a beautiful answer and a beautiful way to close the interview. So what I love about today is that it really showed how it's possible for an economist to enter so many fields, and as well for other fields to enter basically the field of economics and the importance of interdisciplinarity, and also to see that the worries that many economists actually have are very, very common and also difficult to approach, and it is not something to be just assumed away. Thank you so much for your time, everyone, and we hope to see everyone else at the listeners today and viewers at the next episode. Thank you.